Hello my dear learners, how are you all? My dear students, today I'm going to teach you a very important and productive topic that is chemistry of alkanes. And today we will cover the physical and chemical properties, means all the physical properties including melting and boiling points and their densities and their solubilities and their flammabilities and their viscosities and with the physical state. And we will also discuss in detail about the chemical reactions of alkanes. So if you understand chemistry of alkanes well, then you get the chemistry of all aliphatic compounds, because the chemistry of alkanes means the chemistry of parent aliphatic compounds. So the same structural features, the same physical features and same chemical reactions, their patterns will be repeating in almost all of the aliphatic compounds. So here we begin with the name of God. So just we should have a quick revision that alkanes are organic compounds that entirely contain single bonded carbon atoms, and the carbon atoms are bonded to hydrogen atoms. Thus alkanes are the simplest hydrocarbons, if you remember. Then the best definition is they have single bonded carbon and hydrogen atoms. The bonds are totally covalent, right, which is formed by mutual sharing. And one thing more about the whole group of alkanes, that if we talk about all alkanes collectively, if we talk about their homologous series, there is a definite ratio of carbon and hydrogen. So elemental ratio is followed by all alkanes, and we can write the general formula as CnH2n plus 2, where n means the number of carbon atoms per molecule, right? So here few of the examples are just depicted or represented. I talk about propane, consists of 3 carbons and 8 hydrogens, and by adding just one CH2 group, methylene group, we get butane. Then pentane, 5 carbon alkane, and hexane, 6 carbon alkanes. Now one thing is very obvious through these structures, that all bonds are single. The bond between carbon and hydrogen and the bond between carbon and carbon. So here we continue to discuss the physical properties of alkanes. Now we are using so many alkanes daily. We are burning our stoves to cook our food in kitchens, and we are using methane, and we are using liquid alkanes in these lighters. So this is how we are using them, but we never talked specifically the physical properties. So if we talk in general, all alkanes have got these 3 properties in general, that alkanes have low melting and boiling points. Now you can be asked a reason, or you must know the reason for their low melting and boiling points, because they are purely covalent compounds. That is why if I compare the melting and boiling points of alkanes with other ionic compounds, they have collectively low melting and boiling points. And second point is that they are insoluble in water, because water has got polar nature and these alkanes have non-polar, purely covalent nature. That is why they are not very much soluble in water. And for the same reason, for having non-polar nature, they are very willingly soluble in organic solvents, because I often use this proverb that like dissolves like. Alkanes are non-polar and organic solvents are also non-polar, so they are mixed very easily. Now when I talk of the physical properties collectively of all alkanes, I can see the regular increasing and decreasing trends, and you must be very vigilant in this aspect, that the questions will come from these facts. If I talk about the homologous series of alkanes, I am talking about all alkanes increasing molar masses, and the series begins from methane. Okay, so if I say across the series or down the series, means I am talking about the smaller to higher members of alkanes. So there is a regular increase and decrease in physical properties, and the major three properties will be in discussion: the melting points, the boiling points, the solubility, and sometimes the physical state is also the part of the question. So I can see this table is showing you that when I talk of melting point, there is a regular increasing trend of melting point as well as boiling point. So they are on rise. They are from more negative, they are turning into less negative, then we are getting positive values. So on general, the melting and boiling points are increasing across the series or down the series. When I see the densities, the density is also regularly increasing. Okay, if I could relate the physical state, the first four members of the alkane series are very lighter, having very lowest melting and boiling points ranges, so that's why they are found in gaseous state. And from carbon 4 to around carbon 16, the alkanes are found in liquid states, and more than 17 we found viscous solids. So we'll talk about them one by one. If I talk about the melting and boiling point increasing trend across the series, I must say that what is the logic behind this increase? The logic is the increase in molecular mass. The increasing molecular mass is the reason for the increase in melting and boiling point. As the mass increase, the volume, the body of the alkane increase, more stronger forces, van der Waals forces, which can bind the molecules together. So the increased intermolecular forces of attraction, the increased van der Waals forces between or among the molecules, becomes the reason for regular rise in melting and boiling point. The next thing, if we talk about their viscosity, viscosity is the property of a liquid, which means its resistance to flow. So as we see the viscosity of alkanes across the series, we find them being more viscous. So across the series, with a regular increase in molecular mass and molecular size, the alkanes are getting less viscous. The alkanes are getting more viscous. They become resistant to flow because of their increased intermolecular forces. The next very important and applicable part of alkane is that they become less flammable. Flammability is the property of a compound to catch fire. So they become less flammable. And this flammable decreasing nature is just due to the increasing percentage of carbon. As we study the series, we see down the series the percentage of carbon or the contribution of carbon is increasing. So that is why the percentage increase of carbon results in the decrease in flammability. Now next we will talk about the chemical properties. Alkanes are the parent of all aliphatic hydrocarbons which lack any functional group. Now functional group is the reactive site of any compound. Means as alkanes have all carbon-carbon and carbon-hydrogen strong covalent bonds, they lack any special reactive site, they lack any special functional group. That is why alkanes show very less reactivity towards general reactions of other organic compounds, and for the same reason alkanes are also referred as paraffins, having very little affinity. They have very little affinity or tendency for general reactions. That's why alkanes were called as paraffins. Now we see which reactions are observed with alkanes. The very important and applicable reaction is combustion. You know what is combustion? Combustion is a chemical reaction in which a compound is burned with oxygen to give carbon dioxide, water vapor, and energy. And for the same reason, alkanes are mostly used as fuels because they are producing energy when they burn with oxygen. So this is what which is observed with all alkanes. If you are asked to write combustion of methane, you will write CH4, the molecule of methane, burn with oxygen to give carbon dioxide and water vapor plus energy. So you need to balance it. So it goes like this. Okay, and you can be writing for the combustion reactions of other alkanes as well, but remember that two must products are carbon dioxide and water vapor, and the essential condition for writing combustion equation is oxygen. In presence of oxygen, combustion takes place. Combustion never happens in absence of oxygen. The next thing, very interesting and detailed chain equations for understanding substitution reaction. Substitution reactions are those reactions which are simply understood by writing as replacement. Now these replacement reactions involve the replacement of some atom or group of atom by a more reactive species. Suppose if I present it in the form of models, this more reactive atom is coming to replace this triangle. Okay, suppose this triangle is least in reactivity. As this oval atom is coming, model is coming more reactive, and the reaction is it replaces or displaces the least reactive part and take its place. So this is how. So you can talk in general that this species has replaced a least reactive species and make a bond with it. So when I write in form of equations, you can first understand it. A substitution reaction with halogen is possible in case of alkanes. So alkanes react with halogens in the presence of light. All those chemical reactions which take place in light, those reactions are called as photochemical reactions. So it's a kind of photochemical reaction. For example, photosynthesis takes place in light, so that's also a kind of photochemical reaction. So the reaction of alkane with halogen, and what halogens are reacting? What are halogens first? Halogens are group 7A elements. You remember that? Including fluorine, chlorine, bromine, iodine, astatine. So out of these halogens, the reactions are observed with chlorine and bromine. So in this reaction, chlorine and bromine replaces or displaces hydrogen atoms from methane to give the products. So we can write the equation like methane is CH4, like carbon is having 4 covalent bonds with hydrogen, right? When it reacts with chlorine, a molecule of chlorine is a diatomic unit. In the presence of ultraviolet rays means light. So one of the hydrogen atom will be replaced or substituted by chlorine, and remaining 3 will be at their places. And this lost hydrogen will combine with another atom of chlorine to give a byproduct HCl. So in this reaction, you can see this chlorine has substituted hydrogen. That's why we have especially named this reaction as substitution reaction. But the reaction does not stop here. It goes on. It goes on and on and on until all of the hydrogens are substituted. So in the form of equations, I can write all the steps for this reaction, and I can also say that this is a chain reaction because it happens step by step, right? Okay, now you have to see, during the chlorination of methane, it goes on in chain. So it's a chain mechanism which happens step by step. Okay. Okay. In the first step, methane reacts with chlorine to give chloromethane, and the reaction proceeds. During second step, this chloromethane reacts with another molecule of chlorine to give us dichloromethane. This is what it has, the stage where two chlorine atoms are substituted. And in the next step, this dichloromethane reacts with another molecule of chlorine in the presence of light to give us trichloromethane. So this is what, three hydrogens are substituted, and the fourth hydrogen is replaced or substituted in the last step to give us tetrachloromethane. And you see, in the first step, first hydrogen was substituted, and step by step until step 4 has come, all the hydrogen atoms are substituted by chlorine. And you know that this trichloromethane is commonly called as chloroform, and this carbon tetrachloride, you must know it. Why? Because both of them are very important organic solvents, and we are preparing them using methane. Anyhow, this was the whole discussion of alkanes. I have performed my part. Now this is your turn. You just try solving, test yourself 22.2 to get it properly, and just see what is the question pattern from this topic. Thank you for watching the channel. Just keep on, just try learning chemistry happily, because if your concepts are clear, you will be facing your exam with more confidence, and I'm putting my part in your success. Thank you very much, and wait for my next video, and don't forget to subscribe the channel and pressing this sign bell icon. Thank you very much. May God bless you. Allah Hafiz.